Hey everyone, in this video we'll be solving systems of linear equation word problems graphically. So our first example, Carla starts with $40 in a bank account and deposits $20 in the account each week. Martin starts with $100 in a bank account and deposits $10 in the account each week. If X represents the number of weeks and Y represents the total amount of money in each account, then first create a system of equations to model this situation. So the nice part is they've already defined the variables for us. They created the let statement. So if this last sentence wasn't here, that's the first thing we would want to do. Define our variables that we would use in the equations. Now we want to create an equation for Carla and for Martin. Okay, so for Carla, $40 is going to be the fixed amount, right? That's how much is starting in the bank account, so that's the y-intercept. And $20 is the rate at which she's putting money into the account each week, so that's going to be the slope. So the equation would be y equals 20x plus 40. And then for Martin, $100 is the fixed amount, so that's the y-intercept. $10 is the rate that he's depositing in each week, so that's going to be the slope. So the equation is going to be y equals 10x plus 100. So now that we have our two equations, we want to solve this system graphically. Okay, so again, Carla, y equals 20x plus 40, and Martin, y equals 10x plus 100. Okay, so our first line, we know the slope is 20, and the y-intercept is the point 0, 40. For the second line, we know the slope is 10, and the y-intercept is 0, 100. So the first thing we need to do is figure out how to scale the axes. We need to make sure that both of these y-intercepts are on the graph, and because we have positive slopes, we want these y-intercepts to happen lower on our y-axes, so then we can plot points on each of these lines, right? If 40 or 100 are up at the top of the y-axis, then all of our points will go off the graph. Okay, so first, x is the number of weeks. So I'll label that axis number of weeks. And then y is the money they have saved. So I'll just use the money symbol. Okay, so looking, we have 20, 40, 10, and 100. So let's look at scaling by tens. Let's see what that would give us. So 10, 20, 30, 40, 50, 60, 70, 80, 100, and there's still plenty of points to go. So that's going to be the best way to scale the y-axis. So we'll go by 10, so I'll label every 2 as 20, just so we don't have as much writing on our axes. So 80, 100, 120, 140, 160, 180, 200. And here, number of weeks, so let's just scale that by 1. So again, every 2 boxes will be 2, just so we don't have as much writing. 8, 10, 12, 14, 16, 18, and 20. Okay, so we'll start by graphing the line to represent Carla. So we have 0, 40, so there's our y-intercept, slope of 20. So based on our scale, a slope of 20 is up 2 boxes over 1. Up 2 boxes over 1, and we'll continue that pattern. And then we'll graph our line. Okay, so that's going to be Carla. So here, when we label in these word problems, we can either label it with, in this case, the person, which each line represents, or we could also write the equation. I think it's going to be helpful to label with the person so that if we have questions to answer after, we know which person is with which line. Now graphing the line for Martin, so 0, 100, there's our y-intercept. Our slope is 10, so remember, each box on the y-axis is 10, so that's up 1 over 1. And we can graph our line. Okay, so that is Martin. Okay, so the two lines intersect at this point here, and that's going to be helpful for answering the next question. It says, after how many weeks will they have saved the same amount of money? Well, when the two lines intersect, that means that Carla and Martin have saved the same amount of money, right? Because they have the same y value at this point, right? And this is the point 6, 160. So after how many weeks? It will be after 6 weeks, right? So once they make that deposit on the 6th week, they'd both have $160 in their account. And then who will save $200 faster? Well, looking at the y value of 200, Carla achieves that amount in her account after 8 weeks, where Martin is going to take 10. So Carla is going to save faster. Okay, so in the beginning, we can see Martin has more money in the account, but then Carla is equal and then passes him. Now, another thing to talk about, why we only graphed the first quadrant, right? Positive x and positive y. Hopefully we all understand that the other parts of the graph wouldn't make sense. It wouldn't make sense to talk about a negative number of weeks, and we're not going to have a negative number of dollars. That wouldn't make sense either based on this word problem. Our next example, Sam borrowed $700 from her parents to go on a school trip and plans to pay them back $50 per month. Peter borrowed $400 from his parents to go on the same trip and plans to pay them back $25 per month. If x represents the number of months and y represents the amount still owed, then first create a system of equations to model the situation. So again, they've already helped us out. They've created the let statement. They've defined the variables. So that's one less thing we have to do. So now we have to create an equation for Sam and an equation for Peter. So Sam borrowed $700. So that's the fixed amount. That's how much she borrowed. And then she's paying them back at a rate of $50 per month. So that's the slope. But she's paying them back. So she's trying to reduce the amount she owes them. So the slope should be negative 50, not positive 50. Okay, so take a second to wrap your head around that. Right? She's trying to lower the amount owed. Y is the amount owed. So her equation is y equals 700 minus 50x. Right? From the $700 loan, she's taking away $50 per month, 50x. You could write this as negative 50x plus 700. If you want it in mx plus b form, more familiar, both of those are correct. And then for Peter, y equals, he only borrowed $400 and is paying them back at a rate of $25 per month. So $400 loan, and then he's going to subtract $25 each month, so 25x. So we have our two equations, and now we'll go to the graph. So we have Sam and we have Peter. So y equals 700 minus 50x, and y equals 400 minus 25x. Okay, so for Sam, the slope is negative 50, and the y-intercept is 0, 700. And for Peter, the slope is negative 25, and the y-intercept is the point 0, 400. So again, we have to talk about scaling our axes. Now in this case, because we have negative slopes, we want the y-intercepts to happen high on the y-axis, because then all of our points are going to work down. So we need to figure out a scale that makes sense based on all of our values that put 700 and 400 higher up the y-axis. And just before I forget, let's label x is the number of months and y is the money owed. Okay, so let's see. Let's start with 25. Let's see what that would be. So 25, 50, 75, 100. So that's every 4 boxes is 100. Does that get us high enough? So 100, 1, 2, 3, 4, 200, 1, 2, 3, 4, 300, 1, 2, 3, 4, 400, 500. So that's no good. We don't get high enough. And again, don't think you have to get this perfect on the first time. Try. You have to be willing to try with these scaling problems. Might not work the first time, but that's okay. Maybe that gives you some insight as to what you could have done better, and then go back and fix it. So let's try 50 now. So that's every 2 boxes is 100. So 100, 200, 300, 400, 500, 600, 700. So that will be good. So every 2 boxes, let's label 100, just so we don't have a lot of numbers on our axes. So we have 200, 300, 400, 500, 600, and 700. That should be good enough. And number of months, we'll just go by ones again. So every 2 boxes will be 2, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, so now we can graph. So for Sam, y-intercept at the point 0, 700, slope of negative 50. So each box on the y-axis is 50. So this slope's equivalent to just down 1 box over 1. Down 1 over 1. And we continue that pattern to get more points on the line. And we'll go all the way till we intersect the x-axis. And then we connect all of our points. So that's Sam. And then for Peter, we have slope of negative 25 and a y-intercept at 0, 400. Okay, so 0, 400. Now, if we try to go down 25, we'd be going down half a box over 1. That's a little tough. Okay, so let's think about this. Negative 25 over 1. Well, 1 box is 50. So what is that equivalent to if we make 50 the numerator, or negative 50? Well, that would be equivalent to negative 50 over 2. I multiply the top and the bottom by 2. So that means to graph a slope of negative 25 using the scaling that we created, we're going to go down 1 box over 2. And that would be equivalent to going down half a box and over 1. Now down 1 box over 2, continue that pattern to get more points on the line. And again, we'll go all the way to the x-axis. Now we connect our points. And that's going to be Peter. Okay, so the next question asks, when will they owe the same amount of money? Well, the point of intersection between the 2 lines is right here. And that's the point 12, 100. So they will owe the same amount of money after 12 months. Right? So that 12th month payment, they're both going to have $100 left on their loan. And then who will pay off their debt faster? Well, that's essentially asking about the x-intercept. Okay, so Sam has an x-intercept at the point 14, 0, so 14 months to get $0 owed. Peter, 16, 0, so it's going to take him 16 months to owe $0. So Sam is going to pay off her debt faster. Perfect. One more example. A chef goes to a local supermarket to pick up veggie burgers and sausage. 4 packages of veggie burgers and 2 packages of sausage cost $44. 2 packages of veggie burgers and 6 packages of sausage cost $72. How much does 1 package of veggie burgers and 1 package of sausage cost? Okay, so we'll start by defining our variables. So let x be equal to the cost of veggie burgers, a package of veggie burgers, and y equals the cost of sausage. Now, this is not typically a word problem you would think to do graphically, so we'll see how it differs than the other two, right? The other two, there was a fixed amount and a rate. Those two made a little bit more sense. This, we're just given some information to create a system out of. So now that we've defined our let statement, we've defined our variables, we have 4 packages of veggie burgers and 2 packages of sausage cost $44. So that means 4x plus 2y equals 44. And then 2 packages of veggie burgers and 6 packages of sausages, so 2x plus 6y equals 72. So now let's go to our graph. So 4x plus 2y equals 44. And let me just check on that other equation. 2x plus 6y equals 72. So in this case, both of our lines are in standard form. So we could choose to solve them in y equals mx plus b form, slope-intercept form, or we've talked about how to graph a line in standard form. We find the intercepts. And that's actually going to be really helpful for also figuring out what our scaling is. Okay, so we actually want to find both the intercepts here. So I'm going to move this line over there. So for this first one, let's look at the x-intercept and the y-intercept. So as we've discussed, the x-intercept is a point whose y-coordinate is 0. So we'll substitute 0 in for y. So 2 times 0 is 0, so we're left with 4x equals 44. Divide both sides by 4, x equals 11. And then the y-intercept is a point whose x-coordinate is 0. So doing the same thing, substituting 0 in for x now. And we get 4 times 0 is 0, so we have 2y equals 44. Divide both sides by 2, y equals 22. So 0, 22 is the point. Now let's find the same 2 points for our other line. So again, x-intercept is a point whose y-coordinate is 0. So we have 2x plus 6 times 0 equals 72. 2x equals 72. Divide both sides by 2, x equals 36. And then the y-intercept, a point whose x-coordinate is 0. So 2 times 0 plus 6y equals 72. So 2 times 0 is 0, 6y equals 72. Divide both sides by 6. Y equals 12. Okay, so again, x represents the cost of a veggie burger, so cost of a veggie burger. And the y-axis represents the cost of a sausage. Okay, so let's first figure out our x scaling. So we need 11 and 36 to fit on the x-axis. If we can get it so they're both nice points, we'll do that. If not, we'll have to get as close as we can. So to get 36, let's see scaling by 2. Let's see what that would do. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. And that's pretty close to the end. So we're going to have to scale by 2s. Now, that means 11's not going to plot perfectly on the x-axis, but I think if we're scaling by 2's, we can approximate it well. So we have 2. If I'm going by every 2 boxes, then this is going to be 4, right? So it's 2, 4, 6, 8, 10, 12, 14, 16, and then we'll just go 20, 24, 28, 32, 36, and 40. And then we need to scale the y-axes, so 22 and 12 fit. So they're both divisible by 2, and easiest thing is let's just scale by 2's again. So every 2 boxes will be 4 then. So 8, 12, 16, 20, 24. And we don't have to go any higher. Okay, so let's graph this first line using the intercepts. So we have 0, 22, and 11. So this box is 10, 12, so 11 is right there in the middle. Connect those 2 points with a line. Now here, one equation doesn't represent like Sam and then Peter. They're just combinations of veggie burgers and sausages. So let's label it with the equation 4x plus 2y equals 44. So we know which line is which. Now plotting with the other 2 points, so we have 36, 0 as the x-intercept, 0, 12 as the y-intercept. And we will connect our 2 points, label our line, 2x plus 6y equals 72. Point of intersection is right there, which is the point 6, 10. And remember, what were we trying to figure out? We were trying to figure out how much one package of veggie burger and one package of sausage cost. So the point of intersection is going to solve for the value of x and y that solves this system. And x was the cost of a veggie burger, y was the cost of a sausage, a package of sausage. So that's our solution. That tells us exactly how much one package of each costs. So one package of veggie burgers costs $6, and one package of sausage costs $10. And there we have our solution. Hey, this one's a little bit different, right? Because we didn't have a y-intercept and a slope, we used the 2 intercepts. But the nice thing about the intercepts is they helped us figure out what the scale of our axes should be. Then we just plotted the 2 points, right? Minimum we need to graph a line is 2 points. So we had them. And then we just connect them with a straight line to find the point of intersection. Okay, so we saw 3 different types of word problems that we could solve graphically. So now it's your turn to practice and really focus on that scaling. Make sure your graphs look good so you can read the information off of it.